Hello everyone. In this video we're going to be doing our Quick Start video guide for our Profile Nest module. I have on the screen here the Profile Nest Quick Start Guide part. Initially when you run the product you may see some dialogues over here on the left depending on which module you have loaded at the time. For now we'll close them all. Now, from the Home tab in VisualCAD, we'll drop down the VisualCAD main menu and pick Profile Nest. Now, let's move the Machining Objects browser down below our Machining browser, and we'll also resize the browser so we can see everything clearly. Let's take a moment to review what we will do in this video. First, we're going to load the Profile Nest module and define the machine setup, including the post, nested sheet stock, alignment, and more. Then we'll create our 2.5 axis profiling toolpaths for each of our parts that we want in the nest. We will then set our nesting parameters and execute the nest. We will perform a cut material simulation of the parts in our nest as well as the nested sheets. We will also perform some editing by adjusting some parameters and then re-executing the nest. Okay, let's get started. If you're familiar with our nest module, you'll know that you can nest geometry onto a sheet representing your stock. Here in the Profile Nest module, you can nest the actual 2.5 axis profiling toolpaths. So you just need to create the toolpath once and then allow the Profile Nest module to nest those toolpaths onto the sheet stock. Let's have a look at the machining browser. Starting from left to right, we have the Profile Nest button. This button is a module button that allows you to toggle between the different modules. If you click on it, you see that you can go quickly from module to module. To the right, you have a Nest tab and a Simulate tab. The Nest tab is where you go through the process of creating your profiling operations. Then you have the Simulate tab where you perform cut material simulations. If you're already familiar with our mill module, a lot of this workflow will be very familiar to you. So let's go ahead and get started. The part I have loaded is located in the Quick Start folder of the Program Data folder. You will see the part named Profile Nest Quick Start Guide. There is a Start Part version and also a completed version. In the part file, you only need to draw the profiles that you want to nest. They are shown here. Down below the parts, we have a rectangle that represents the nested sheet, with the bottom right corner of the rectangle located at the WCS origin. You will also notice that each part should be located outside of the sheet rectangle. You don't have to draw your sheet rectangle. You can create it just by entering some dimensions, and I'll show you how to do that in a moment. So let's start the process of nesting these profiles. On the Nest tab, we're going to start from the left and work our way over to the right. First, we'll select Machine. You will see that there is only one option for the 3-axis machine type, so we'll just pick OK. Next, we'll select Post and set our current post processor to the Laguna BR IQ. Now let's create our stock. From the Stock menu, we will select Box Stock. We want the stock to be the dimensions of our sheet, so we'll enter 36 by 24. We're going to give it a thickness of 1/4 of an inch and then pick OK. You can also turn the stock on and off using the toggle icon located here. Now that we've got our stock, let's go ahead and set our sheet parameters. I mentioned earlier, if you don't have geometry created and you want to specify the sheet, you can give it a name and length and width and thickness here, and then pick Add Sheet to define the sheet. Since we already have our sheet rectangle drawn, we're going to use the Select Curves option. Then we'll select our rectangle and then right-click. You see that it adds the sheet definition to the dialog. You see that there are multiple columns for defining the sheet. Let's set the sheet thickness to 0.25 and leave the sheet count to 1. Later on, I'll show you how to calculate the sheet count automatically. Now we pick OK to close the dialog. Now, let's make sure our stock is aligned to our sheet definition. Let's change it to an isometric view to see it better. We'll pick Align Stock from the menu. So here is the corner of our rectangular sheet geometry. For Z alignment, we'll select at bottom, because we want the bottom of the sheet stock located at the WCS world origin. This will move our sheet up to the XY plane. Then we'll set the 0 position to southwest. This will move the bottom corner of the stock to the WCS origin, and then pick OK. Now, let's make sure our stock is toggled on, and we can see that the stock is aligned like we want. Now we'll assign a material to the stock. We select Material from the menu and set the material to Wood, and then pick OK. If you want to see a material texture on the stock, there is a toggle for that right here. Typically, I just leave it toggled off for now. We defined our machine, post, sheet, stock, alignment, and material. The Work 0 option here on the menu allows you to assign a Machine Coordinate System or MCS origin point. This should match the machine 0 on your router. If we don't set a Work 0 here, the MCS origin by default is located at the WCS origin. You can see here that we can toggle the display of both the MCS origin and the WCS origin. It is important to understand that the MCS origin should match where your machine 0 point is located on the router. Ours is at the bottom left-hand corner of the sheet. Since that is the world origin and the MCS is already located there, we don't need to define an alternate Work 0. Now, let's move back to the top view, and we're ready to create our first 2.5-axis profiling toolpath. We go to the 2-axis menu and select the 2-axis profiling operation. This displays the 2-axis profiling operation dialog. For the Control Geometry tab, we'll pick the Select Curve Edge Regions button. Then window select our first part and then right-click or press Enter. We see that the geometry was added to the dialog. Even though there are multiple curves selected, it will be treated as one profiling operation and will be nested as one part. Now let's go to the Tool tab and select the Edit Select Create Tool button to display the dialog used to define cutting tools. First, we will select Flat End Mill from the top toolbar. We enter the tool name as Flat Mill-0.25. Set the tool diameter to 0.25 and set the tool material to HHS, or high-speed steel. For the Feeds and Speeds tab, you can set these to suit your needs. Now we select Save as New Tool, and we see that the tool was added to the Tools in Session column on the left. We'll pick OK to close the dialog. Now we move to the Feeds and Speeds tab and pick Load from Tool. By doing this, you will assign the feeds and speeds you defined in the tool to this operation. Now we go to the Clearance Plane tab and set the clearance plane to Automatic, and then set the Cut Transfer method to Clearance Plane. Now we move to the Cut Parameters tab and set the tolerance to 0.001 and set the stock to 0. We'll enable Use Inside-Outside for closed curves and then select Outside. We will also enable the Alternate Using Nesting option because our part has interior cutouts. Next, we go to the Cut Levels tab and set the location of cut geometry to at bottom. We'll set the total cut depth to be 0.25 and leave the rough depth and the rough depth per cut at 0.25 also. The operation will make one cut level pass at the bottom of the stock. Next, we'll go to the Entry Exit tab. For entry motions, we'll select a long path to generate a ramp entry and set the ramp angle A to 5 degrees and ramp height H to 0.3 just above our stock sheet. We want to use a ramp entry so that the entry motion does not extend out past the perimeter of the part. This will keep the nesting as compact as possible. Then for the exit motions, we'll select None. Next, we select the Advanced Cut Parameters tab and enable Cut Arc Fitting and set the fitting tolerance T to 0.002. We will also enable Bridges and Tabs and accept the default values for these. Now we will go to the Cornering Parameters tab and set the external corner type to Sharp. This will keep the tool from rolling around the corners, maintaining a sharp edge at the sharp corners. Now we go to the Nesting Parameters tab and set the count to 25. There will be a total of 25 of this operation in the nested sheets. Now we pick Generate to see our 2-axis profiling operation on the first part. Okay, let's take a look at the toolpath. We have an external path and interior paths. We have bridges and tabs and sharp corners. Now we need that same operation applied to the remaining 3 profile curves. We will right-click on the first operation and select Copy. Then right-click again and select Paste. This will make a copy of the operation and paste it below it in the machining job tree. We will do this 2 additional times so that we have a total of 4 operations. Now we will rename each operation. Just right-click on the first operation and pick Rename. Enter Part 2 at the end of the name. Then we'll do this for parts 2, 3, and 4. Now we need to change the control geometry for parts 2, 3, and 4. Just right-click on Part 2 and select Edit from the menu. From the Control Geometry tab, we will select Remove All, and then pick the Select Curve Edge Regions button. Window select the geometry for Part 2 and then press Enter. Then we'll select the Generate button. We will do this again for parts 3 and parts 4. Okay, now we have one 2-axis profiling operation for each of the 4 parts defined in the way we want them. Next, we will select the nesting parameters from the Nest tab of the machining browser. Here is where you decide how you want the parts nested onto the sheets. We will adjust the orientation angle to 45 degrees. We will set the distance part to part to 0.125 and the distance part to sheet to 0.125 also. We'll accept the remaining parameters and then pick the Estimate Number of Sheets button. If you recall, we mentioned that you did not need to know the count value in the Sheets dialog. The system will calculate and then adjust the sheet count automatically for you. Now we're all set to execute the nest. We'll pick the Execute Nest button. The nest is calculated and the sheets are generated and added to the machining job under Nested Sheets. If you select a sheet, you will see the nested 2-axis profiling operations for that sheet. Now is a good time to get a nesting report by selecting the option from the Nest menu. This provides some additional information about the nest. You can also get an estimated machining time for each sheet by right-clicking on the nested sheets and selecting information. Now, let's perform a cut material simulation for both the original parts and for one of the sheets. Just select the operations to nest, right-click, and select Simulate. The 2-axis profiling operations for each part are simulated. Now, currently we don't have any stock defined outside of our sheet stock. You can double-click on Stock box from the machining job to change your stock dimensions and then perform the simulation again. Now, to perform a cut material simulation on your nested sheets, just select a sheet, right-click, and pick Simulate. You can also adjust the simulation speed if you want, or select Pause and then 2N to see the completed sheet simulation. Now let's do some editing. Let's say, for example, that you want this part here to always be aligned as it is drawn. There is a sharp corner on this edge that we want to maintain. So we will edit that part's operation. Go to the Nesting Parameters tab and check the box named Fixed, and then pick Generate. You see that the nested sheets is now flagged. This alerts you to the fact that your nested sheets need to be updated. To do this, we go back to the Nesting tab and pick Execute Nest. The nest will be updated, the flag removed, and we see that each of these parts are now fixed in its orientation. So anytime you edit one of your profiles, just execute the nest to see the new results. Now, if you look inside one of the sheets, you see that there is a 2-axis profiling operation for each part in the nest. You can edit these operations from here if you need to. However, just remember that all sheets are regenerated when the Execute Nest option is picked, so it's best to edit your source profiles instead, if possible. Now, let's post some G-code. You can post just the source operation if you like, or you can post an entire sheet. We'll right-click on Sheet 1 and pick Post. The G-code is displayed in Notepad. Okay, we're done. If you have any questions or need additional support, just give us a call or visit us online at www.mecsoft.com. This video was brought to you by MecSoft Corporation, your CAM partner.